Pleasure to be here. And I hope it will be an annual event. Solar Eclipse.
Yeah.
Let me just find out. Show of hands. How many people have seen solar eclipses? Have seen one? A total. Maybe about 10 people. How many have not? Probably about twice as many. So maybe about a third of you have seen one and 2/3 have. My first eclipse wasn't a total, it was only a partial. But it was back in 1963. It was a total up in Maine, but I was at my grandparents' summer home, and I was an amateur astronomer at the time. I guess I was 11. This was the first eclipse I had seen, but it was interesting enough, even as a partial phase, that I looked at my little golden book of astronomy and saw that there was going to be a total eclipse in the U.S. in 1970. It seemed an infinite amount of time away, but it was on my calendar then. So when 1970 rolled around, by that point I had just gotten a driver's license, and the eclipse path crossed Mexico, Florida, and along the east coast of the U.S. I got my parents to let me borrow the family car and drive down to North Carolina and to catch the solar eclipse from down there. And I had one of these generic 60mm department store telescopes with a camera hooked up to it. And I thought I was pretty prepared for the eclipse because I had read Sky Telescope and I had read the books, and I knew all about what the eclipse was going to be, and I was ready to photograph it. And amazingly enough, I actually managed to get some photographs of it, although the film snapped in the middle of totality because I was applying so much pressure. This goes right on to Fred and Jen's talk about things that go wrong. And I had thought, preparing for this eclipse, that this was one of these once-in-a-lifetime events. I had to see it. But within seconds of third contact, the end of totality, I said, when's the next one? One is not enough. I knew there was one, I already knew at that point that there was one in Mexico in 1991, and I was already planning for that. This is 1970. I said, even that is too long to wait. And I went up to Canada in 1972 for an eclipse that went through Quebec. I was flagged out there. So that was one of the first hard rules you learn about eclipse chasing is that just because you know when and where to go, the weather doesn't always cooperate. In any case, since then, I've traveled all over the world to eclipses, to every continent. This is sort of my world map of every location where I've been to either a total, annular, or partial eclipse, including Antarctica. Interesting side note on Fred and Jen's experience in Antarctica. I was on the other end of the eclipse track, far away from where they were. I saw the eclipse on November 24th. No, I saw it on November 23rd. No, I saw it on November 24th. They saw it on November 23rd, but I saw it before they did. So the gas went through my part of the path first. So when you get all the date lines crossing so close together, it gets very confusing. But anyway, I've traveled all over the world for these eclipses because they're such exceptional events, so spectacular, and you only have a few brief minutes typically to see the eclipse. So I want to just share briefly a couple of quick eclipse experiences just to give those of you who haven't seen a total eclipse a little bit of an idea of what you're in for next year. This was an eclipse in 2008 that primarily went through Central Asia, into Mongolia and northern China. I brought a group to northern China for the eclipse. And this is the type of equipment I'll bring to an eclipse trip. The big consideration here is it's got to fit into 2 standard airline suitcases with a 50-pound limit, with a judicious amount of underwear, socks, and t-shirts just for packing purposes. And it often helps if your life partner is coming along too, because then you can use some of her things about the 2008 eclipse was that it was so late in the eclipse path that the sun was quite low in the sky. I think it was only about 10 or 11 degrees above the horizon there. So you get a good feeling for the shadow. In this case, you'll notice that the sky over here is a lot darker. That's the direction the shadow is coming from right to left in this image. And that's just about the beginning of totality, the diamond ring effect. And I realized in going through some of these photographs that we've been taking selfies with eclipses long before they were called selfies. This is sort of a wide-angle time-lapse, and you can see that shadow sweep across the sky from right to left. Here's Venus right up there. This is only about, I think, a 1 minute or 70-second long totality. It's quite brief. Total eclipses can last anywhere from a fraction of a second up to about 7.5 minutes. Why the duration varies depends on how close the moon happens to be during the Earth, during the eclipse, which part of the Earth the path crosses. If it crosses within the equatorial regions of the Earth, Earth's rotation helps you chase the shadow, so to speak, and keep up with it a little bit longer. And this tends to extend the duration of totality. Here's some still frames shot with one of those telescopes of the diamond ring breaking up into Bailey's beads, and of course totality itself with the corona. Here's a little video that catches some of the excitement.
50 seconds. Shadow to the northwest. 30 seconds. 25.
So you'll notice I've got the filter off quite a ways before totality, so I get the diamond ring.
Corona. Venus.
All the clips are my camera. My camera.
Bailey's beads. Totality.
And there's a little bit of prominence up about 1 o'clock there. This video is going to jump forward about 60 seconds to the end of totality. But the moon is moving from right to left, and you'll see how much that prominence gets uncovered towards the end of the eclipse. See quite a bit more of it now.
30 seconds.
Look at the horizon.
25 seconds. Oh, look how bright it's getting. Look at the shape of the shadow cone.
You see it? See it? See that beam over there?
15 seconds. Chromosphere. 10 seconds.
Chromosphere. 5 o'clock. See that shape? Oh my God, here it comes.
Here it comes. Beads. Bailey's beads.
Take pictures, take pictures.
Don't laugh, you can do the same.
You can always tell when totality starts.
Yes.
Yeah, people will ask questions, well, when is the safe to take my filters off? When it sounds like the Super Bowl touchdown. It's safe then, because everybody goes wild. And I think the most constructive thing about this video isn't the image itself, it's the people and the voices and the reaction and the excitement. Another still shot right at the end of totality with Bailey's beads. And then what causes the Bailey's beads? Those are bits of sunlight shining through the deepest valleys along the edge of the moon, right before totality either begins or ends. And they typically only last a second or two. They last longer if you happen to be at the very northern or southern edges of the path, because the moon's limb moves tangentially along the edge of the sun. So that's one of the benefits of being at the limits of the eclipse path. The duration of Bailey's beads and the chromosphere is extended, and some people make that a special. For me, it's all about the corona, and I want to stay pretty close to the central line area to maximize the duration I spend in the shadow to observe and photograph the corona itself. image, wide angle image in the totality. And one more experience, this was just a few months ago in Indonesia on March 9th this year. And in that case, I was on a cruise ship, the American Eclipse. I guess we had about 1,500 people or so on that ship, and most of them were there for the eclipse. Not everybody. I had breakfast with people that said, oh yeah, we booked the trip, and after we got on board, we found out there was an eclipse going on. Can we borrow some eclipse glasses? Of course, there were plenty of eclipse glasses that we passed around. But on eclipse day, there was some concern about the weather. Even before we went, we knew that the prospects of seeing this eclipse were probably only about 1 out of 4. Weather in that time is right at the beginning of the monsoon season in Indonesia around the equator. So the prospects were not really promising. But it was a great opportunity to do an eclipse from a cruise ship. This doesn't happen all that often. But this eclipse morning, everybody getting ready. And to reiterate what Fred mentioned before, if this is your first eclipse, try to resist the temptation to set up cameras and shoot pictures of it. Watch it. And this is a perfect way to watch a total eclipse. Naked eye and with a pair of binoculars. This woman's got a pair of binoculars with some white light solar filters on the front of it that she can quickly pull off during totality and then watch totality with it. And then pop those filters back on again. That is the best way to watch an eclipse. Now, that being said, some of us can't help ourselves. We have to photograph it, we have to record it. I've been to 26 total eclipses now, and I have tried to photograph every single one. And people ask me, when are you going to stop photographing and watching? I don't know. I haven't reached that point yet. Well, there was a lot of concern on eclipse morning. This was about maybe a half hour after sunrise, a lot of clouds around, and the ship was still underway. We were not parked in our final destination because in order to make our next port of call, the captain had to sail the ship up to the path of totality, stop there, see the eclipse, turn right around, and keep on going. So we were en route at that point. And even during the partial phases, the sun was in and out of the clouds. So it was a bit nerve-wracking, sort of a wide-angle view of the entire sky there. But at the right time, we moved into a very big, large, clear patch of sky. I don't know if it was just luck or the skill of the captain, but he gets the credit nevertheless. And that was the little portable system I had on board the ship. And this is sort of a time-lapse of the sky during totality. I think the duration was around 2.5 minutes for this eclipse. And I want to show one more video. This one again to catch excitement. I'll also show you how quickly, I think this captures how quickly the sky darkens.
Congress coming to the west.
So this video camera has a fixed diaphragm. It's not going to change the exposure.
Filters off.
So diamond thing is taking place right there. Now, what really amazed me about this means as dark as night, even though you'll read that over and over again in the newspapers. It's more like about the darkness of the sky, perhaps about 30 to 40 minutes after sunset, when you've got a medium twilight. It's dark enough to now pick out the brightest planets and maybe a few first magnitude stars. But you're plunged into that twilight in 10 seconds, from a relatively bright sunlight to this twilight. So subjectively, it feels a lot darker than it is. For the first 8 or 10 eclipses that I went to, I always carried a pocket flashlight in case I couldn't read my camera settings. And I never needed it, and I don't carry one anymore. Barring the problem that Jen had, not being able to read the little window on the back of the camera. I've never needed a flashlight to see any camera settings. A couple of still shots from the deck of the ship. And one of the goals that I always do is to shoot a bracketed set of, many bracketed sets of exposures in order to composite roll to a high dynamic range image of the corona. And that's sort of a quick first cut. I need to get back to this data set. Other demands have cropped up. For instance, giving talks on the 2017 eclipse. But it was a wonderful weather for this eclipse. We were very fortunate. And of course, as soon as the diamond ring formed, we were thinking very much about 2017 and the Great American Eclipse through the U.S. Why is this eclipse so particular? Why is it getting so much press? It is the first total eclipse to pass through the continental United States in 38 years. The last one was in 1979, so we have had this very long eclipse drought of total eclipses here in the U.S. You've had to travel to other parts of the world to see total eclipses. The eclipse path is the entire region where the eclipse is visible is outlined by this large region here. And you can see it's comparable to the most of the daylight hemisphere of the planet, maybe 2/3 of the daylight hemisphere. The path of totality, of course, is much smaller. It's this narrow pair of blue lines down here that are about 70 to 72 miles wide. And you've got to be in that narrow path for the total eclipse. This little animation cartoon gives you an idea of the dynamics of how the eclipse progresses. The large shadow is the moon's penumbral shadow. We only get a partial eclipse from inside the penumbra. But the total eclipse is from that little umbral shadow there, that little spot that's sweeping across the U.S. That's only about 70 miles wide in this particular eclipse. So depending on where you happen to be, will determine when the eclipse takes place, what time of day, and whether you're in the penumbral or umbral shadow. Now notice, even if you're in the path of the total eclipse, the penumbra also sweeps over you, so you will see partial phases before the total phase, and then partial phases after the total phase. So just to bring that point home again, this is sort of a snapshot. The penumbral shadow much larger. Depending on where you are, positions B, C, D, E, and F give you different amounts of the sun covered up as you're at different distances from that central path. But it's only in the central path where the moon is completely obscured and you get to see the sun's corona. So when people say, it's a 90% eclipse, it's a 95% eclipse, that's almost 100%, isn't it? Well, numerically it is, but phenomenologically it's nothing near it. There's no comparison between a 99% partial eclipse and 100% total eclipse. Because it's only in that path of totality, 100% completely covered sun, that you get to witness the sun's outer corona. That region of visibility of the partial phases, notice how large an area it covers. Parts of Asia, even a little bit of southern Europe and western Africa, as well as the northern half of South America will see the partial phases. The entire length of the central path, where it's total, is about 8,600 miles, and it takes the moon shadow a little over 3 hours to circuit that 8,600 miles. section of the path, which is a scant 2,500 miles, and it covers that track in an hour and a half. This is Michael Zeiler's beautiful map of the 2017 eclipse. You get a better idea of the real estate covered by the eclipse. It sweeps through the states of Oregon, Idaho, Wyoming, Nebraska, a little bit of Kansas, Missouri, Illinois, Kentucky, Tennessee, North Carolina, and South Carolina, and just a corner of Georgia. Now, a lot of people are concerned about the weather prospects. What's the weather going to be like? This is some of the type of tables and statistics that my partner Jay Anderson comes up with. He's a Canadian meteorologist that I've worked with for 20 years on eclipse predictions. And there's a lot of information and material and tables like this to absorb. He's got a lot of this stuff online. I've got stuff like this in our bulletin on the eclipse. But you will be thankful to know that you will not see another graph like table like this in the rest of this talk. It's too much to absorb just looking during a talk like this. What I am going to do is simplify some of Jay's weather information with these little icons here. These blue boxes show you the amount of cloud coverage in the sky as measured from satellite data. And the green boxes give the cloud amount measured from ground stations like airports or meteorological stations. In both of these cases, large numbers mean lots of clouds, small numbers mean sunny. You have to remember that. It's sort of counterintuitive. You have to remember you want small numbers for those two things. Except for this one. This is a third measurement, and this one is just the amount of sunshine possible in a given day. Again, this is measured from ground stations, usually airports, and not all airports measure this sort of thing. In this case, you want a large number, because it's the fraction of the day where you have sunshine. So there's three different ways of depicting the cloud amount at various locations along the path. And most places don't have all three numbers available. Anyway, we can think of the eclipse path of 2017 as grossly broken up into three large geographic areas. The first one is the Rocky Mountain and Pacific states. And in this part of the eclipse path, meteorologically speaking, you get a mixed cloud climatology that's determined very much by the mountain ranges in this part of the country. We start off on the coast of Oregon. Here we've got the eclipse path. I'll explain a couple of the details on these maps. For one thing, of course, here's the northern limit and southern limit of the eclipse path. These pale gray lines indicate the duration of totality. So you can see, or if you can't read it, that's 30 seconds, 60 seconds, 90 seconds, 120 seconds. So you get most of the duration. You can be quite a distance off the central line and still get most of the eclipse. It's only when you get very close to the edges where the duration drops just precipitously. Another thing on these maps, I'm giving the universal time, the duration of totality on the central line. In this case, 1 minute 56 seconds, and the altitude of the sun in degrees. And those type of things are going to be on all of these maps coming out. There's some of the weather information, which I'll speak to in a minute. And that satellite, those blue boxes determined from satellite, I'm going to give a word of caution there. Those statistics are determined from a pixel size 1 degree by 1 degree square. So you can see there's not a lot of granular information in that. So small features like mountain range and stuff tend to get blurred together. So these are very gross numbers in these blue boxes. They're only for relatively comparing one station to another rather than fine details of why one small little region is better than another, because it's based on a very large area, 1 degree by 1 degree square. Getting back to the weather, Lincoln City Beach along the Oregon coast is the first landfall. So some people who might want to have take the bragging rights of being the first to see the eclipse might be tempted to go there. However, the coast of Oregon is known for having morning fog, and you'll see that's reflected in the weather statistics. There's 65% chance of cloud cover, and including fog. So that's a risky location to be in. When the shadow moves inland, it crosses over the coastal range, which is only about 3,000 feet high. That tends to dry out the clouds a little bit as the shadow sweeps across the Willamette Valley down here. In the Willamette Valley, you've got Salem and Albany and Corvallis. That's prime locations. And the weather prospects there tend to be a little bit better, 55%. A much better predictor, or a much better dryer of the weather and bringing out the moisture in the weather is the Cascade Range running through here. That's about 10,000, 11,000 feet, and that tends to really dry out the moisture out of the atmosphere. So that by the time the shadow reaches into the Columbia Basin, the numbers have dropped quite a bit, down to 35%, 25%, 80% sunshine here. Madras, Oregon here has the best statistical weather prospects along the entire eclipse path. So they're going to be a busy place for the eclipse. There's a lot of people who go there with the promise of clear sky. Continuing into eastern Oregon, the land slopes gradually upwards, climbing up to the Snake River Plateau. And in eastern Oregon also there's some weather statistics. You can see, because it's climbing upwards into some more mountainous terrain, you tend to start developing some higher probability of clouds until you get to the Snake River Plain up here, where it gets better again as the shadow goes down. Another popular destination will be the John Day Fossil Beds in Oregon here. A nice little park there with some interesting scenery and pretty good weather prospects. Continuing into Idaho, the Snake River Plain sort of wraps around the Sawtooth Mountain Range here. Sawtooth Range is right there. And that's reflected also in the statistics. You've got about 35% in the Snake River. It increases when you go over the Sawtooth Range, and then improves again when you get into the eastern end of the Snake River Plain. Boise, Idaho is just outside of the eclipse path, unfortunately. Nevertheless, it's a good staging area. It would be a convenient place to fly into, big international airport, relatively speaking, for that part of the country. And it would be an easy drive to get into the eclipse path on eclipse day, or to go into the state outside the eclipse path. But the forest fires nearby were so intense, the smoke was so bad, that there were times when you could look directly at the sun without solar filters. The smoke was that thick. And if you're anywhere near something like that on eclipse day, it might be good for looking at the partial phases, but you wouldn't be able to see the corona at all. So that's one thing you have to be prepared to respond to, especially in the western half of the eclipse path. Reaching the Wyoming border, the shadow crosses over the Teton Range, right through here into western Wyoming. Cloud prospects tend to increase again, crossing over the mountain range, as that warm air climbs up, it cools and condenses, and you get cloud formation. Nevertheless, Jackson Hole, because it drops down again, has relatively reasonable weather prospects, especially if you can respond to forecasts. And that becomes the problem with the Tetons. It's probably the most picturesque, beautiful location along the entire eclipse path. However, even without an eclipse, this is August and it's the height of the tourist season. And it's a crowded place. You've got the Grand Teton Park right here and Yellowstone right up here. So it's a major destination for vacationers. Throw in a total eclipse and it's going to be a traffic jam. So I'm really scared of that particular location, especially if you want to be able to move at the last minute and change your position because of weather as well. Just a couple of shots taken from the Tetons, just to get an idea. Very often in Jackson Hole in this valley here, very often it'll be clear and sunny, but clouds up in the mountains behind you to the west, which is okay because this occurs in the late morning, so the sun is going to be to the east away from the mountains. Here's a view from up on the mountains, looking down into Jackson Hole, and you see the clouds forming above the mountains, but down in the floor of the valley, it's nice and clear. This is a MODIS image from orbit of a typical scenario on eclipse day, the type of cloud you might expect to find along the eclipse path. There is some cloud offshore in Oregon with a lot of clouds. They sort of dissipate a little bit as you get into the Willamette Valley. You cross over the Cascade Mountains and it almost blocks all the clouds right there, brings all the moisture out. So that down into Madras here is nice and clear. And then as you start climbing up into eastern Oregon, you start getting some cumulus cloud buildup randomly here and there until you get to the Snake River Basin again. And it's clear. This is the Sawtooth Range of cloud buildup. The other side of the Snake River plain again, relatively clear. And then, in this case, this letter here, G, is forest fire material. Smoke from forest fire. The central part of the U.S. can be considered the Great Plains part of the path. And in that case, the climatology is basically dominated by the daily formation of cumulus clouds in the afternoon. Now, the eclipse occurs early enough in the day. In this part of the path, it occurs around noontime or early afternoon before convective clouds tend to form a little bit later in the afternoon. So hopefully, if you've got a typical pattern like this occurring on eclipse day, the cooling of the Earth during the partial phases might help inhibit the formation of some of the cumulus clouds. Typical weather, and Wyoming is sort of on the edge of that Great Plains area. We've got the Casper over here with about 45% probability of clouds. 70% clear sky. You'll notice these statistics don't add up with each other because they're measuring different things in different ways. The point being here that it's relatively good weather prospects in eastern Oregon, promising enough that the Astronomical League has chosen Casper to hold their annual convention there. And that's where I'm going to be heading. At least a week before the eclipse. A lot of people have asked me, where are you going for the eclipse? And I say, well, I'm going to be in Casper the week before the eclipse, but 24 to 36 hours before the eclipse, I'm basically going to find out what the weather forecast is. And if I need to, I will jump in the car, I'll be mobile, and I could be anywhere from western Idaho to eastern Nebraska by eclipse time. Traveling across a nice thing about the Casper is you've got the good road systems. Let's go back up. You've got Casper here. You've got a state highway running 100 miles to the west, right along the central line, and to the east you've got an interstate highway that curves down, but then you've got state highways again that slowly curve you back into the eclipse path. So there's a lot of running in that area. If you want a really unusual place to watch the eclipse, in Alliance, Nebraska, you've got Carhenge, kind of a tacky location on Stonehenge to view the eclipse. It's probably going to be crowded as well. Imagine there will be a lot of American Druids there worshiping the Cadillacs. Crossing into eastern Nebraska, North Platte is just inside the eclipse path, although it still gets a good 90 seconds, about 1 minute less than the central one. It's still a good duration and a good jumping off point to get deeper into the path. And you've still got I-81 following the eclipse path. Here it curves up into the path. And you've got Grand Isle right in the center of the eclipse path. A very good destination with I-81 there, so you can travel east and west if the weather prospects look threatening the day or two before the eclipse. And weather prospects still reasonable, about 50% chance of cloud cover. At this point, the shadow sweeps into Kansas and Missouri, and at this point, you're getting typically more of the moisture from the Gulf of Mexico moving in to feed the convection engines that produce these convective cumulus clouds in the afternoon. It's also getting a little bit later along the eclipse path, early afternoon now, once you get into Missouri. So it's a little bit more of a concern. And one thing you have to keep in mind in all these statistics is all the stuff is based on statistics on climate over several decades. But you have to keep on reminding yourself, this stuff is climate, but on eclipse day you get weather. So all this stuff can be out the window. It's good for long-term planning and comparing one location versus another. But the key, I think, to seeing the eclipse is to be flexible and to be mobile around the eclipse time, especially with an eclipse like this one that passes right through the U.S. with great state highway system. Kansas City, the southern limit cuts Kansas City, bisects it. So depending on where you happen to be in Kansas City, you'll get a deep partial eclipse, a beaded total eclipse, or tens of seconds of totality. So I'll be interested. I'm sure that the news media is going to be pulling their hair out trying to figure out what to tell the public about this. We're going to have to resort to some type of maps on where the eclipse is total and where it is. This is one of Jay's graphs, which is kind of interesting. This is based on the satellite data. And there are two curves here. The red curve, or dark red, dark brown curve, is the amount of cloud cover at the 7 a.m., basically 7 a.m. from satellite data, because that's what was available. The blue curve, I think, is for like 3 p.m. in the afternoon. So what you want to consider when you look at this is the red curve is good for the western part of the eclipse path that occurs in late morning, whereas the blue curve is what you want to apply for the eastern half of the eclipse path. And interesting thing to note in the western part is this oscillating behavior. Well, what's going on there is every time you reach a mountain range, the clouds increase on the western side of the mountain range because they're predominantly westerly winds, and the warm air rises producing clouds. You get into the eastern end, and they've dried out and it clears up again. So that's the cause of that oscillation. You don't see nearly as much, but in the eastern U.S. because we don't have the large mountain ranges. And speaking of the eastern part of the eclipse path, that's the eastern third of the path. That tends to have the highest amount of cloud cover because it's being fed by moisture not only from the Gulf of Mexico, but from the Atlantic, and it's later in the day when convection has had more of a chance to have buildup. So starting in the extreme western end of that path, we've got the eclipse path bisecting St. Louis. They've got the opposite situation from Kansas City, where the northern half is outside of the path and the southern half is in the eclipse path. And then the path crosses into Illinois, where we reach the point of greatest duration, just south of Carbondale, Illinois, where the duration is 2 minutes and 40 and a fraction seconds. Now, Carbondale is making a big deal about that. Because of that greatest duration, they're billing themselves as Eclipse City. But not only because they're at the point of greatest duration, but because 7 years from now, they also happen to be at the crossroads of the 2024 eclipse that also crosses through Carbondale. So if you're thinking about some retirement property, Carbondale might be your place, but you can 2 greatest eclipse. The difference between the two of them is greatest eclipse is a geometric point in the eclipse. It's the instant when the axis of the moon shadow passes closest to the center of the Earth. That's the definition of the greatest eclipse. It's actually a tenth of a second shorter here than it is at greatest duration. And these two communities are battling it out. Which place is the ideal, the best place to see the eclipse? Which is kind of ridiculous. They're arguing about a tenth of a second. And I can tell you from personal experience that even if you only have a 10-second total eclipse, a 10-second total eclipse in the clear is better than a 2-minute, 40-second eclipse in clouds. So weather is the driving, my point is, weather is the driving force of the eclipse day, not the duration or totality in the central line. You should be paying attention to what the weather is telling you where to go. You know, load up the car with a cooler of drinks and food. The only reason you need to stop is for gas and toilet breaks. Go for chase good weather. That's the goal. You can see that the weather prospects are slowly creeping up in terms of the cloud amount as you head east, up to 70% here. But still, some contradictory information here because the amount of sunshine is still 63%. They're measuring some different things, slightly different. Nashville is towards the southern edge of the eclipse path, but they still get over almost 2 minutes through downtown Nashville. Right outside of Hopkinsville, at the point of greatest eclipse, is an unimposing little sorghum field. And Jay Anderson did a drive along the entire eclipse path about 2 summers ago. And he stopped along this point to see the point of greatest eclipse. And the farmer that owns that field was there and goes, oh yeah, somebody stopped by here twice a week to check it out. And he said that he was thinking about getting his granddaughters to set up a little lemonade stand at the eclipse path. Except the local county would probably charge him an exorbitant amount for a licensing tax to sell a lemonade. So it might be a losing proposition. But they're well aware of the eclipse down there, especially in those two communities. There's Nashville, so you can see how quickly the duration changes, 10 seconds, each one of these is 10 seconds. It's only when you get to the last 2 or 3 or 4 miles where the duration drops a lot. So you don't have to worry about being directly on the central line. If you're within 20 miles of the central line, you're still going to get most of totality. At that point, you should be considering what the weather is doing and other considerations. In eastern Tennessee, the track crosses into North Carolina and into the Smoky Mountains here. They're not called the Smoky Mountains for nothing. You've got the worst weather prospects along the entire eclipse track, and because of the moisture, even though the mountains aren't very high, it's still enough to produce a lot of cloud in that region of the path. Even though it would be a very picturesque location. Finally, we get to the easternmost section of the U.S., primarily through South Carolina. We've got Columbia here, deep in the eclipse path. Greenville is deep in the eclipse path. And Charleston, right here on the coast, is off the central line, but deep enough into the path that it gets, a minute, 90 seconds in downtown Charleston. So there are opportunities for lots of people in metropolitan areas to see the eclipse. The central line is, I got the map on this. There we go. There's a little Buckhall recreation area right here on the coast. And the interesting thing about that is if there happens to be a sea breeze on eclipse day, that will tend to blow any cloud formation inland. So it gives you a little bit of an edge in terms of weather prospects. But again, it requires a sea breeze in order for that to take advantage. At that point, the shadow moves across the Atlantic Ocean and spends the next 70 minutes or so over open ocean without another landfall. So another reason why this is called the Great American Eclipse is that there is no landfall on this eclipse except for the USA. And that's the first one since I think around the 13th century. There's an eclipse path that only crossed U.S. territory. Now, Michael Zeidel has produced some interesting graphics on how close the American population is to the 2017 eclipse path. And this shows that within a 200-mile driving distance to the path of totality, almost 88 million Americans, or 27% of the population, is within a 200-mile drive of the eclipse path. We expand that a little bit to 400 miles, we get 174 million. Over half the country is within a 400-mile drive, less than one day drive to get into the eclipse path. We expanded to 600 miles, over 81% of the nation is within a 600-mile drive. Now, I just want to point out the unfairness of this because I live down there. As do the folks in New England have the longest distance to get to the eclipse path. Not that I'm complaining. It's a lot closer than Antarctica. So, the 2017 eclipse, where can you find out more about this event? And there are a lot of resources out there. Jay Anderson's Eclipsophile is the place to go for weather information. He's got a lot of climatological tables like I talked about, but I think even more importantly, in the week before the eclipse, he will be updating it and producing a lot of forecast information and links to forecasts there, so you can keep an eye on what the weather is doing. And of course, he'll be posting stuff with an eye on where the best locations are and what the weather prospects are along the path of totality, rather than just going to the National Weather Service where you're just getting generic stuff from all the U.S. or various regions. He's going to be focusing on the eclipse itself. Michael Zeidel runs Great American Eclipse.com, and he has, without doubt, the most beautiful eclipse maps. He also has some very nice animations on the eclipse. And he's also got a lot of great eclipse swag, filters and nice maps, posters. He's got this beautiful antique-looking map for the 2017 eclipse. You're going to be the best dressed guy in totality. He's got hats and t-shirts and all that. And he's got a table set up out there too for the generous. Another good website is eclipse2017.org, run by Dan McGlown. And I think one of the most useful things that he's got on his website is he's got a page like this for virtually every community in each of the states that the path of totality passes through. And on one side, he has a current look at the weather forecast in that particular locale. And on the other side, he's got a map that you can click on to get the duration of totality at different locations in the path. So that's a very useful resource. That's eclipse2017.org. I started the NASA Eclipse website back in 1996. It's been 20 years now. But I retired several years ago, and I've started a new website that I think supplants it, because all the new stuff that I've generated now is going on eclipsewise.com. So you might want to take a look at that. And of course, I've got a page dedicated to the 2017 eclipse that I keep adding material onto. I think one of the more useful things is a Google map of the eclipse path plotted on it, and if you click at any location on the path, it'll pop up a balloon and give you the times and duration of the eclipse from that particular location. And of course, like any Google map, you can zoom in and you can look at where various highways cross, and you can get information that way. I won't give you a URL for that. It's just easier to Google EclipseWise 2017 Total Solar Eclipse, and you'll find some of that resource. I'm on Facebook. Welcome friends to friend me on Facebook, and I frequently post updates and information about the 2017 eclipse, more so in the coming year. In the years that I worked at NASA, Jay Anderson and I published a series of eclipse bulletins, each one usually each one focused on one specific eclipse, with lots of information on that particular eclipse. Well, after we were both retired, we had to figure out a different way to do it, and we came up with print on demand, so that we don't have to order 2,000 of these things and fill up our garage. These things are printed as you order the books. So we published a detailed book for the 2017 eclipse, and now we've got it available in color too, which we didn't have that option with the government. So we've got both a color and black and white version. This has more information about the eclipse in it than most people want. There's also a road atlas that I published, detailed maps of the road. If you think you're going to be on the road chasing the eclipse, chasing good weather, this will tell you what the duration is at any location in the eclipse path, or at least a close estimate. My wife wrote a children's book about the eclipse, where her granddaughter's modeling for it. And we've also put together a general guide for the general public for eclipse classes. And I'm working on an updated version of my book with Mark Lippman on totality on the 2017 and 2024 eclipse. It's not in print yet. It should be available by early January.